Hello, welcome to this video on partial derivatives. We're going to look at a very strange looking function. There's so many terms involved. There are variables x and y everywhere. And we're interested in taking the partial derivative of this function, evaluate it at a particular point. We'll do the x partial evaluated at 0, 1, and later we'll do the y partial as well. The purpose behind this example is to show you how these, let's say this whole video is about showing you how to, this is one way to think about basically what a partial derivative really is. So when you have an x partial, what you're doing is holding y constant, treating y as a constant. And then you're going to go plug in for that y. You can flip that process and plug in for the y first. And so replace all of your y's with the 1 because y is supposed to be constant. And it'll take this ridiculously complicated looking function and dramatically improve upon it and have it more simple. So first plug in y equals 1 and then take the derivative with respect to x. Watch what happens when y is equal to 1. First term, it's just sine x. Second term, it's just cosine y now. Now third term is a y squared minus 1 inside of an arctan. It's the arctan of 0. Then this last term is natural log 2e to the sine x minus 1 times the secant y times the tangent of y minus 1. That's tangent of 0. That whole term zeroes out. You're actually just left with sine x plus cosine x. Now you take the derivative with respect to x of that. And so you get cosine x minus sine x. Now you plug in x equals 0 into that. Cosine 0 is a 1, sine of 0 is a 0. The x partial of this ridiculously complicated function, evaluated at 0, 1, is just a 1. Let's do it again for the y partial. At 0, 1. So now x is constant. That should say for fy. Sorry. And so replace the x with 0 and then take the derivative with respect to y. And we get even greater simplification. You see, go back to the original function on the first line there. Replace all the x's with zeros. Sine of 0 is 0. Cosine 0 is a 1. We have arctan of 0, 0. Natural log of 2e to the 0. It's a 1, but then 1, which is e to the 0 is a 1 times 2. 2 minus 1 is a 1. It's the natural log of 1, and all the rest that's there too. But it's, natural log of 1 is 0. Arctan of 0 is 0. And this function, with all the x's being replaced by 0, it's a 1. You don't have to take a derivative. Oh, I'm sorry. The function is a 1 and its derivative is a 0. Zero. All right. Great. I just want to introduce you to some very important equations that involve the partial derivatives. You see, that's where calculus gets most of its applications. It's from differential equations. And in Math 241, you actually have a chapter on each one of these special equations. So they're called partial differential equations. They're equations that involve partial derivatives. Nothing that we're going to do with these, but I just want you to know that if you go on and take the next, or the next class after that, a class that's just in abbreviated PDEs, partial differential equations, you learned about partial derivatives here first, and now you can go apply it. And we can solve these equations. I mean, people have been given Nobel Prizes for the solutions to one of these equations applied to economics. The heat equation, where you look at options of financial options to buy a stock, and figuring out how to price that. That led to the Black-Scholes equation, and the scientists there, they won a Nobel Prize by presenting that and solving it. And then the wave equation, that's mostly to do with sound, how it propagates. And there's also Laplace's equation. So I just want you to know what these things are. Okay, we talk about partial derivatives, so just want to introduce you to partial differential equations. Now I really want to focus for the rest of this video on trying to understand what the number is that you're calculating. When you go to calculate this x partial, what does it really mean? And so you have a surface where we're only showing the first octant here, and on the surface is the point 1, 1, 1. So when x is 1 and y is 1, you plug it in, you'll get z is equal to 1. The surface is z equals 4 minus x squared minus 2y squared. And if you were to take the x partial, you'll get negative 2x. Evaluated at 1, 1, it's a negative 2. The answer that we get for this is a negative 2. But what does it mean? You see, the x partial is, if you're standing at that point 1, 1, 1 on the surface, and you want to measure how the surface is changing, the steepness of the surface, when you take the x partial, you're taking the steepness of the surface in the direction that is parallel to the x-axis. You see, y is constant when you take an x partial. So just like we did in that numerical example, we can plug in y equals 1. We can look at what happens as y equals 1. Y equals 1 is a plane. It's hard to see, but it's at the bottom left corner there. That's the plane that slices your surface and turns it from 3D really into 2D and gives you a curve of intersection called C1. And now you're back in 2D world and you want to know what the derivative is to C1. It's the tangent line. That red line there is the tangent line to that curve, and its slope is what you're measuring. This negative 2 that you get for this derivative is telling you that when you change x by 1, the z function goes down by 2. Change x by negative 1, the z function goes up. So, it depends on which direction you're stepping, in the I direction or the minus I direction. All right, so now that we understand what we're measuring, let's flip it and talk about the other guy. What about the y partial? Well, with that one, you're holding x equal to a constant. That's like slicing with the plane x equals 1, seeing the intersection now who's called curve 2, and finding the slope of that curve at that point. And so the y partial is minus 4y. It's steeper. You're steeper in the y direction than you were in the x direction. The slope is minus 4, meaning that you increase y by 1, then z should go down by 4. And so that's what's going on here with the meaning behind the number that you calculate. Let's go ahead and end the video here. Thank you for watching. My name is Nakia, here to help you through this journey. I want you to know what these things are and how to work with them, how to calculate things. Comment down below, like and subscribe. If you have any questions, reach out to me, and I'll see you in the next video. Thank you for watching.